My name is Andreas Jochen and this is my Kickstarter project. This is an electro-permanent magnet that can be used to pick up and drop off cargo with a quadrocopter or a small plane or a robot arm. The advantage is that you don't need any electricity or power to in static operation. You just need a little bit of energy to switch the magnet on or off. An alternative is to use an electromagnet. An electromagnet in this for 100 Newton of force, which you would need to hold 1 kilogram securely with a factor of 10 safety. You would need about 200 watt, which is not doable for a small quadrocopter or a small airplane. Now, let me explain you how it works. Here we got a magnetic circuit. Those are U-shaped transformer iron. They will be conducting the magnetic flux. And here we have two neodymium magnets. A compass. This side is south because it pulls the north needle. Put this on here. So this side is south. This side is also south. We put them together. Now, this side is south, this side is north. The magnetic field lines are open. Okay, here's a little bigger piece of iron. But as you can see, this is south, this is north, and the field lines are close to this iron. And hence you have a force. Now, let's switch one of those magnets around, like so. Now, this side becomes north, and this side becomes south. Now the field lines are close to here, and you have no external field. As you can see, you can't lift up anything. We do it again. We have the okay, now you have an external field again. Okay, where are you? Now, magnets have a property called coercitivity, which correlates to the amount of magnetic field you need to switch its polarity or switch its poles around. For neodymium, it's about 1000 kA/meter, which is very high, but it's doable. For example, here we have a copper coil. With this coil around a magnet, we could switch the magnetic poles around and basically make this an open or a closed magnetic circuit. Basically, you will be able to pick things up, switch the poles around, and drop it off. Now, alnico magnets have a coercitivity of only 50 kA/meter, which is a lot better and much easier to work with. Okay, here's the prototype. It consists of a power supply. It's a basic buck converter that takes in anything up to 36 volts and puts out 15 volt here at about 100 milliampere. This is used to charge up this capacitor bank. It's 7500 microfarad to this charge resistor. Now, and with this switch, we will discharge the capacitor through the coil around those neodymium and alnico magnet pairs. With this switch, we select its polarity. Basically, we will align the neodymium, the alnico magnets in the same direction as the neodymium magnets to have an open magnetic circuit and an external force. The other way around, we will align them against the neodymium magnets and close the magnetic circuit inside this apparatus, and therefore you will not have any external fields and no external force. Now, to show you, okay. This is basically made of two pieces of transformer iron and those little neodymium and alnico magnets. Alnico magnet not shown here. And it's the same principle as we've seen before. If we turn one of them around, we have either open circuit, and then we turn them around again and we have a closed circuit. The same principle. Now, in operation, okay, Okay, now we discharge the capacitor to the coil and the magnetic circuit should be open, so there should be an external force. This is a package that has a metal strip glued on it and you can lift it up. Now also notice there is no static electricity required for static operation. It will operate itself. Now we charge up the capacitors again and discharge them in the other direction. We'll drop it off. Do it again. Pick the package up, drop it off. It has a maximum force about 10 newtons. And the production version will have a pulling force of 100 newton, which equates to 10 kilogram force on this planet. Good enough to secure 1 kilogram of cargo. And also expected size is to be under 50 gram, about a tenth of the size of this thing. The switching will be done by MOSFET, via MOSFET, preferably logic level MOSFET that can be driven directly by any microcontroller that supports logic level 3 or 5 volt output. And I just got this in the mail. It's the new APM 2.5 autopilot from 3D Robotics, and it will be fully compatible with this. All that's needed is two logic outputs from this, connecting two logic outputs from this to this device, and you can remote control the magnet. Well, thank you for watching my Kickstarter video. I hope you enjoyed it. Goodbye.